Hello, everyone. Welcome to today's Storage Leaders virtual panel. It's great to see everyone today. My name is Doron Youngerwood. I'm really excited to be moderating today's lively debate and discussion. We brought together a fantastic group of leaders from across the storage industry for what should be a really fun and interesting conversation. Just to set expectations, while we have the storage vendors on the panel, this is not about presenting the latest and greatest capabilities or pitching any solutions. The goal is really simple. It's to have an open, candid discussion based on what our panelists are seeing across the industry and across real customer environments. And the reason we brought this group together is simple. AI is fundamentally reshaping enterprise storage. We're seeing new demands on performance and scale, but at the same time, increased pressure around protection, recovery, and resilience. And what makes this panel valuable is the diversity of perspectives. Each of these leaders works with different enterprises, different architectures, and different approaches. So hopefully we'll surface a realistic picture of what's actually happening in the field today and in the near future. The goal for today is to keep things really practical. We'll talk about where storage architectures are holding up, where they're potentially breaking, what challenges there are, and also what organizations should be doing differently as they adapt to AI workloads, especially when it comes to protection and recoverability. And we'll also challenge a few assumptions along the way. Just a very, very quick word from our sponsor, Core 6. Core 6's flagship solution, StorageGuard, continuously validates the security posture of all enterprise and backup platforms to ensure they're hardened, helping you to reduce risk of compromise. It does this by gathering the configuration of the various storage and backup systems and automatically identifying things like security misconfigurations, violations of security best practices, violations of hardening guidelines for each of the storage backup platforms. And it can also report on compliance or non-compliance. So with that, let's dive straight in. And I want to start by introducing our panelists, starting with Amy. Amy Cool is the Field CTO in Europe at Dell Technologies. And we also have Adam Gale, the Field CTO with a specialty around AI and security at NetApp. We have Felix George, the Field CTO at Hitachi Vantara, along with Patrick Fay, AI Storage Product Manager at IBM, Eric Herzog, the CMO at Infinidat, part of Lenovo, and finally, Itzik Reich, the VP Mission Alignment at Vast Data. So before we dive into the first question, I want to encourage all of you to use the Q&A panel. It should be at the bottom. It might be on the side. Please ask questions throughout the event. We will try to get to answer as many of them as possible throughout, but please ask those questions. All right. Let's start with question number one. This is a framing question. AI is clearly reshaping storage, like I touched on earlier, but from what you're seeing across customer environments, what has started to change most dramatically in the last 6 months? And Patrick, I'm going to pick on you to answer that first question.
Awesome. Thanks, Ron. Appreciate it. Thanks for the opportunity today. So I'll start with a couple of things, less technology focused, then I'll move on to how I think that impacts some of the kind of decisions around storage architecture going forward. I mean, the first is probably no surprise. The demand for AI has put a strain on infrastructure supply chains around the world. Starting with GPUs and compute, then to memory, and now to storage. I mean, I think most people are pretty familiar with just the rapid price spikes of NAND and HDD around the world, and unfortunately, the CIO and the infrastructure budgets didn't go up the same amount, and so that's going to force some real decisions around trade-offs and storage cycle refreshes and all those sorts of things. So, the CFO and the CIO are now getting involved in the storage conversation, and certainly seen that with some client discussions where the executives will come down and say, "Oh, that's too much. You're gonna have to decide what what you're gonna get this year, right?" So that's a very real strain just on the organization, and different than what they were expecting. The other thing I've noticed, and I'm actually very curious to hear from my fellow panelists here, is with all this AI and all the clear benefits that storage can bring to the table, I also unfortunately don't necessarily see the storage admin or the infrastructure folks at the table with AI. I would love to see that more, but in conversations, I'm still often going in there talking about some really cool capabilities that storage can enable for kind of a holistic AI architecture. And oftentimes it's still uh, encounter kind of siloed thinking. Well, we're just bits and bytes and speeds and feeds and so that's been part of my work over the last year is really trying to shift that mindset with our clients. Um, and then the other thing I'd say is more on the technology side, it's, as you're dealing with these pricing pressures and supply chain issues and whatnot, looking for efficiencies. And part of that starts with, well, now we really need to understand actually what's in our storage. We've got all 10, 20 petabytes, whatever you have in your environment. Oftentimes, folks don't even know what's in there. So can you get us insights into into that data? Tell us what's relevant, what's useful. And what's not, of course, so that we can be much more efficient in how we and kind of how we orchestrate across the whole environment.
Amazing. And Itzik, I want to ask you the same question. What, in your perspective, what's changed most significantly in the last, let's say, half a year?
Thanks, Doron. And for the record, I didn't match any version with Patrick just yet, but I think I'm going to touch those points. So, at least to me, what I'm seeing, honestly, the biggest change is not even technical, it's who's in the room. About 18 months ago, storage conversations were between infrastructure folks and procurement, maybe. And now what I'm seeing are CTOs, CDOs, chief data scientist officers, sometimes even the board, asking direct question about storage. As a board member, what do you understand about storage anyway? And it's because the link between storage and AI performance has become something you can put a dollar figure on. So three things in particular have shifted. First, GPU utilization has basically become the new way people measure storage. In the old days, people used to care about IOPS, latency, bandwidth, all in a vacuum. Now they care whether they 300,000 GPU investment, and I'm being very modest here, in many cases it's way, way above it, is these CPUs or GPUs are just sitting idle. And where it is, storage is very often the reason. That's a number CFO understands immediately, the linkage between how utilized the GPUs are. Secondly, the entire conversation around data gravity flipped. It used to be how do we move our data to where the AI runs? Now it's how do we make our data available everywhere instantly without moving it at all? People have realized that moving data as itself is a cost. It's a cost in time, dollars, complexity, and they're trying to design that cost out entirely. And third, unstructured data has gone from an afterthought to the main event. For years, storage was built around structured data, virtual machines, databases, transactions, AI. AI mostly runs on video, images, documents, model weights. A lot of organizations are now realizing their storage estate was optimized for a different kind of data and are now rebalancing, becoming a priority one for anyone serious about AI right now. And if I'm trying to be a little bit too much clever, I think that storage is almost becoming the wrong word for what we're actually talking about here. What organizations are really building is the operating layer their AI runs on. Storage is just a part of it and what people have historically been paying attention to.
Amazing. Really good points, Itzik and Patrick. Thanks for that. I want to talk about performance and architecture, and specifically AI workload impact. Itzik, I'll start with you. How are AI and GPU-driven workloads forcing organizations to rethink storage architecture? Can you walk us through perhaps where storage breaks across the AI lifecycle, if it does?
Sure. So a little bit of introduction to AI life cycle. It's a great question. The short answer, it's different bottlenecks. People talk about AI storage like it's a one thing. It's really not. There are 4 phases in the AI life cycle, and each one stress out storage in a completely different way. So let's start with training. Training is basically a feeding problem. You've got hundreds of thousands or even more GPUs, and they're hungry. They want hundreds of gigabytes a second continuously without dropping off. The thing that breaks first usually isn't the raw throughput, it's metadata. It's the thing that enabled the thing, if you will. When you've got that many GPUs opening and closing millions of files at once, the metadata layer is doing an enormous amount of work, and that's where the real engineering challenge sits. It's why namespace design, how metadata scales as file and clients go, matter as much as raw bandwidth. Checkpointing is a different animal. People underestimate it because it sounds like a background task, but if you're training 70 billion parameter model, that checkpoint might be hundreds of gigabytes, and it all has to land in a burst. If your architecture can absorb that fast, your GPUs are just sitting there waiting. So this is really about write performance under pressure, not the steady read-heavy stuff most architecture were traditionally tuned for. And then there is inference. Inference is really a latency game. Nobody notices your average response time, they notice the slow one. The tricky part is inference usually run right alongside training on the same infrastructure. So unless those workloads are properly isolated, training can quietly eat into inference performance, and you won't even know why your gap feels so slow. And then lastly, there is RAG. This one surprised people the most, I think. RAG basically wants your storage to be a database and a data lake at the same time. Millisecond lookups across billions of objects, vector searches, and high throughput reads all against the same data. Simultaneously, most systems are good at one of those things. RAG need both. So really, that's your answer. It's 4 different phases.
Amazing. And Patrick, I want to go back to you. And if you can shed some light on your perspective of the way AI and GPU-driven workloads are forcing companies to rethink their storage architecture.
Absolutely. So let me build a little bit, I think, on some of Itsek's points there. I'll start with the first is I think we're generally either underestimating or haven't quite absorbed just how much data creation is going to happen with AI. NVIDIA, when I was talking to them a while back, they come up with some estimates. I think they were saying maybe 500 zettabytes by 2029 or 2030. Just as absurdly high number, right? And if you extrapolate that down to every enterprise, it means you're going to need to store a lot more data than you probably expect over the next 4 to 5 years. And why is that? So I'll touch on kind of the inferencing side and the RAG side a little bit. Well, with these RAG architectures, there's this kind of what we like to call this capacity expansion effect. Oftentimes, when you run data through RAG, you end up producing more data than went in. So, for instance, maybe a terabyte goes in, 5 terabytes could come out. I've heard upwards of 15x in terms of capacity expansion. Sometimes it's less. But if you don't size your storage environment accordingly, you're not going to get you're not going to have the capability that you expected. So I think that's often a surprise for customers on the RAG side. On the inferencing side, there's this growing realization around KV cache offload into storage. The KV cache kind of being, I'll call it sort of the memory being produced by the LLM, as it's inferencing, but the memory space in the GPU and the CPU fills up really quickly. So isn't it great if we could just offload that to storage? Wonderful. That becomes a lot of data really quickly, and you need to feed that information back into the wherever you're serving these models, and so then your performance matters a lot. So there's capacity that you probably didn't expect, and performance that you probably also didn't expect. That storage could again become the bottleneck in your AI infrastructure. So I think those are two really important things to keep in mind. And the third I'll mention is, kind of this trend of, can we do AI closer to storage? Well, that probably means bringing compute closer to storage as well. So architectures where the GPUs are very close to storage, so you can really keep those GPUs fed and humming along nicely. So I'm seeing that around the industry, not just IBM, but other folks, getting delivering solutions where the GPUs and storage really kind of that converged architecture again.
Amazing. That's great. I can see a lot of questions coming in, and I'm going to get to them very quickly. I want to ask one or two more questions, and then I'll open up to the audience. And Felix, I'm going to pick on you for this next question. The difference between legacy and AI-ready infrastructure. So, Felix, in your opinion, where are you seeing the biggest gaps between legacy storage environments and what AI workloads actually require?
That's a good question. I don't think the biggest gap is technology. I think it's an architectural intent. As you know, legacy environment were designed to support business applications that were predicted to have predictable workload and a stable growth. Data is today data is being accessed more frequent by more users, by more applications, and increasingly by autonomous agent, quote unquote, the magic shiny thing, agentic AI. So I think the organizations that are being successful aren't simply buying faster storage. They're redesigning the architecture around trusted data flow rather than infrastructure silo. As you know, in the past, we built an infrastructure that was basically focused on forecast, capacity, and performance. And it was a perimeter-based infrastructure. Today, due to AI, that has shifted into a more dynamic, busting environment where if you're planning for capacity, you're already failing. It's basically your infrastructure needs to be able to respond dynamically in real time to demand. You need to be able to implement security guardrails and compliance in real time.
Amazing. That's great. And Itzik, I want to ask you the same question in terms of the main differences or the main gaps between legacy environments and AI-ready storage environments.
Sure, thank you. I want to be fair, I'm a bit sensitive to the word legacy, even though I work for a company that is fairly new. So I think legacy versus modern can sound like a knock on a good engineering. I don't think that's the case. The storage system built over the last decades were generally excellent for the world that they were designed for. What changed isn't that they got worse, it's that the requirements moved and moved very, very fast. And I'd like to point to a couple of places where I think that gaps tend to show up. So I think we touched on metadata and namespace a little bit, but just to expand on them, enterprise storage was built around human scale access, a few thousand users, predictable folder structure. AI doesn't work like this. A single training job can touch hundreds of millions of files and put real pressure on the metadata layer in a way that wasn't really anticipated a decade ago. And that's pushed the whole industry to rethink how metadata scales as data and clients count grows. And I think we also touched it when we talked a little bit, when Patrick talked about KV cache. Second, protocols. AI environment speaks a lot of languages at once. NFS or POSIX for training, S3 for data lake, NVMe over TCP for GPU direct access, or as we call it, fiber channel or block protocol access. Supporting all of them natively with full consistency against the same data is a generally hard architectural problem, and it's one we've put a lot of effort into, the entire industry. Third, the economics of flash, which again, I think Patrick started to touch. QLC NAND has changed the math completely. You can now get NVMe level performance at what used to be capacity tier pricing, but it takes real engineering investment to get there and get there well. That shift is opening up performance and capacity together in a way that wasn't really possible a few years ago. And fourth, and this one is subtle, but I think it matters, unstructured data, again, that we touched before. Most enterprise storage was built around transactional workloads, VM, database, etc. AI, as we touched before, is overwhelmingly unstructured, but it's the accumulation of all of these different workloads into the GPU. So that's the one thing that gets it all together. Every one of these gaps eventually show up in the same place. It's your GPU utilization numbers. When storage is the bottleneck, it just looks like idle GPUs. And GPU time is expensive enough that this stops being a storage conversation and becomes a budget conversation pretty fast.
Yeah, that's a good point. Very good point. All right, I want to pause here and I want to read out a couple of questions from the audience. There's some great questions that have come through. Question number one, and anyone can answer it, anyone on the panel. So Philippe asked, why can we not spread data across disparate multi-vendor storage with an AI front end to manage the data, data placement, protection, and processing?
I can try
Open to anyone who
Carlos.
wants to answer that question.
Sure. I think that it's probably two-way folded. Let's talk about the technical one first, and then we talk into the vendor arena. So on the technical merit, normally when you put some virtualization engine on the top of different products, so then to make them all look like the same product, you become a bottleneck of the lowest common denominator in expense for having the same operational efficiency against the different products. And sometimes it can work and sometimes it can. It really depends on the protocol and the product and think of that nature. Then there are other considerations like data reduction, which can get more efficient on one product versus the other. And if you put them into one cohesive control plane or even a data plane, that can hurt. And then there is the vendor part. I think that each and every one of us has its own incentive maybe to sell their own gear, and we are guilty of it as much as everybody else. And then there is also another layer, I think, that sometimes the protocols, even though they sound the same, they are actually acting very differently. So let's not even talk about our own product. Let's talk about cloud products. The S3 protocol, S3 behaving differently on AWS versus Azure versus Alibaba. So even if we wanted to adapt a standard, there is no standard. So this problem trickle down to every layer, if you think about it.
I'm just going to
Right.
add to that. I actually think the market did try this a fair few years ago with a product. I think it was Viper, I think it was called. Ultimately, I don't think it took off. The engineering effort to marry up all those things that you just rightly mentioned was astronomical, including getting companies to open up APIs as well. So ultimately, I don't think it took off.
Wonderful. Next question. Chandra, he asked the question, do you see adoption of the CXL protocol for storage purposes? And again, open to all of the panelists. Do you see adoption of the CXL protocol for storage purposes?
I'm not seeing it.
I'll take a stab of it. So CXL and KV cache are interchangeable between each other. KV cache is what started this, and CXL is the NVIDIA way of doing KV cache. It's relatively very new. So it's going to take, I think, some time to ramp up.
Amazing. All right, let's move on. Trade-off question. So Eric, I'm going to ask you this question. If budgets are constrained, where should storage leaders prioritize investments today? Should it be around performance? Should it be around capacity, resilience, or something else?
So actually, if you find the right solutions, there's a ways to get all three. Some systems are very good at consolidating other people's systems. So for example, if you've got 288 floor tiles and you can find a vendor that can do all the same workloads in 61, you just dropped your price, both CapEx and OpEx. You don't have to sacrifice, and the money you were going to spend for 288 floor tiles, now you're spending on 61. So that delta can be spent on cybersecurity, AI, or some other IT project. So you need to look at things, and obviously all infrastructure, not just storage, has increased dramatically in the last year, and it doesn't look like there's any end in sight. So hard drives are allocated. They're still less expensive than flash. Flash, which actually was close to hard drives, is actually skyrocketed. So hard drive pricing is up. Flash pricing is up, but up even more. And then there's supply chain issues on all of it. So things like if there's a way to consolidate, because as someone already pointed out, 50% or more capacity isn't even utilized. And it's not that they need a buffer. It's like literally they don't know what they have and they're not using it. So if you're not using it, you just wasted money. And now, when everything is so expensive and lead times are long, you want to make sure that A, you're not wasting 50% or 30% or even 25% of the space, because you need to have efficient utilization of space. So if you do all those things right, you won't have to sacrifice performance, capacity, or resilience. And clearly, I would argue you can't sacrifice resilience, because resilience has multiple aspects to it, right? You can't feed AI if the system isn't available. So the system itself needs to connect to the network, to the GPUs, etc. That's item one. Item two, the data needs to be reliable. If the data is corrupted, then the AI is going to hallucinate because the data is garbage. Third thing is cyber. All AI has done, particularly since AI is mostly a software play, has opened up another attack surface. They were already attacking the moat, right? The Great Wall of China to keep the enemy out. They're attacking that. They're attacking the servers. They're attacking the networks. They're attacking the storage. And now, since AI is not a human doing the work, it's a piece of software doing the work, they can attack the software. So you've actually opened up the attack vector to the cyber criminals even more. So it's hard to sacrifice resilience, because even if you forget the cyber side, if the data is corrupted, doesn't help you do AI. And if the data is good, but the system somehow fails on a connectivity or something else, then you still can't feed, you can't do the inferencing, you can't do anything. So that's why resilience is important. At the same time, as already pointed out, capacity is exploding. So you've got to be able to optimize that capacity. And then clearly, as pointed out, performance for AI, whether it be latency for certain workloads, bandwidth for other workloads. So really, it's very hard to make those decisions. The best thing to do is figure out a way to manage this physical storage better. And if you have the right systems, consolidate from vendor A to vendor B, or vendor A and B to vendor E and F, because they can consolidate, and that does help you better handle the data. Because remember, it's not about the storage, it's about the data that sits on the storage. But if the storage isn't done right, the data is a wreck anyway. So storage is important, even though many of the people in the IT community think, storage. I've met so many CIOs, I've never met one that was a storage admin.
Yep.
Way back when, you might have had a few mainframe admins, then maybe some open system server. And now they're all software guys. So anytime you're talking to the CIO, the CTO, they hate the CDO, they hate storage. They just know they got to buy it. So you've got to kind of translate from what a CDO wants to hear, what a CTO wants to hear, what a CIO wants to hear. And that's all about, hey, if you're doing this AI workload, here's how much better it can be. Or, by the way, you need to spend money on AI. Let me show you how to cut your storage costs so you can spend money on AI, because CIO budgets aren't going up just because AI is expensive, or the componentry that we all sell, as well as the server vendors and networking vendors. Cisco's pricing's gone up. Every server vendor's pricing gone up. So that's why you have to be really careful about thinking that you can sacrifice something, because all you've done is screw up your AI workload if you sacrifice too much.
Yeah, great points. Thank you, Eric. And we'll talk a bit about cyber resiliency shortly. Patrick, same question to you. Where should storage leaders prioritize investments?
Yeah, I don't think I can disagree too much with what Eric said there. I guess I'll add in just a piece of nuance I was thinking about as he was speaking, is in order to make the right trade-offs, I think you really need to understand the use cases from your organization. And so, it's really touched on nicely. AI is not just one type of workload. If you got training, fine-tuning, inference, RAG, all this, going on, what is your organization actually doing? There's going to be some that are building these mega GPU clusters and going to be running these big continuous training jobs. Then there's going to be other customers that are most likely just going to be inferencing heavy. And depending on those workloads, that's going to determine some of the decisions around, do I really need top of the line performance, or can I maybe shave off a little bit of that, focus more on getting the right capacity? I also agree with their resilience. I think that's just something that needs to be built into the system that you're purchasing. Along with that, I know it's not, I wouldn't call it quite resilience, but I'll probably call it more like data governance. I mean, you really need to make sure that the data going to AI, especially for inferencing, is only data that you want the AI to have access to. So if there's PII or sensitive information, or it's very not GDPR compliant, that sort of thing, you have to make sure it's screened on the front end before it gets to the AI model. And you definitely want to have access controls in place, because you do not want the intern getting the pre-release financials for quarterly results on accident. That would be a really big problem. So all of these things are even more important in the world in AI, not that they weren't before, but you really have to have that control around the data, and doing that in storage is just a logical place to make sure it gets done.
Excellent. All right, let's transition over to the evolution of ransomware. And Adam, I'm going to ask you this question. Storage and backups are now primary targets for ransomware. What's a ransomware attack pattern that you've seen in, let's say, the past year that perhaps you haven't seen before?
Sure. So I think personally, they absolutely are a target. And I think historically, we've faced a lot of focus on the perimeter, identity, networking, everything. And potentially we've overlooked the value of protecting our storage, considering, it's keeping our keys, it's keeping the most important bit, our data, which we are struggling to attain a value for. It's so valuable for us, we're struggling to put a quantitative number on it. So we absolutely should be protecting it. And I love the word of resiliency now, because it kind of implies that on a long enough timeline, we will be subject to a breach. So let's be more resilient. So framing it in that, what we are seeing is maybe a threefold attack. You've got the traditional sort of breach, encrypt, and then ransomware, which we've seen many of. They're very well publicized. Then we're seeing the second event, which is where they've extracted the data at the same time, and then they come back 6 months later and they'll ransomware you again, because they've got a copy of the data, or they'll sell it on the black market. And then you're seeing the third, which is wrapped up in that backup, which you mentioned. They're potentially corrupting backups or corrupting some data. So when you restore back into production, you're actually restoring the issue back into production. It could just be a hole somewhere that they got in. And this is a threefold attack. So you have to defend against all of this, which is kind of difficult. I mean, it's become such a recognized issue now that there are literally regulations that have been written that say, go build a clean room, go build an area where you can store clean copies of your data and then put them back into production. Because if this starts hitting critical infrastructure, which it is, and it will, you can affect economies. So that's certainly something that we're seeing. And I think finally, just to wrap it up, something I see quite a bit, which is frightening, is targeted attacks. Targeted. So they're looking at C-level people, and with the use of AI, you can scrape unlimited amounts of information on them, and then really go after individuals and potentially bribe them or harass them to giving over the keys or doing something. So we have a really new sort of threat evolving now, I think, where you need to defend against, which is even harder. So I would say that. And that sounds like I'm being really negative, but I promise you I'm going to say something positive in the next question.
I look forward to that, Adam. Same question to Felix. Any new ransomware attack trends and patterns that you've seen recently?
Sure. I'm going to echo some of the point that Adam mentioned. So what we're seeing is some of the biggest changes is that attackers are no longer focusing on solely on encrypting production data. They are going after the recoverability itself. They're targeting privileged accounts, backup infrastructure, replication path, immutable copies, and recovery environment. Their goal is not simply disruption anymore. It's basically eliminate the confidence that recovery is even a possibility. And that changed the conversation from a backup strategy to a cyber resilient strategy. Based on my experience back in the days when I used to run a storage team, I remember the organizations where they were very confident and that they should be. I estimate that about around 1/3 organization that I talked to, they discovered meaningful gaps the first time they perform a realistic recovery exercise. In those cases, usually the backup wasn't the problem. It was that the sequence of recovery, the application dependency, the identity systems, and the operational process. Those were the gaps that I seen. I remember a customer showing me these beautiful dashboard. Everything was green, and basically he said my backup worked perfectly. And I look at him and say, unfortunately, that will not be able to restore your business if you're a victim of a ransomware. So the lesson that I always try to, and the message that I try to give my customers is that a successful backup will not guarantee a successful business recovery.
Yeah, really good point. Thanks, Felix. I will get to a few of the questions from the audience shortly. I want to ask one more question to Amy this time. Amy, I always believe that many organizations assume recovery will work when needed. In your opinion, how often is that assumption actually wrong? Can you perhaps put a number to that, but estimate a percentage?
Yeah, so I could say 67% of IT decision makers were not confident they could recover all business critical data after a destructive cyber attack. However, we see numerous slides that cite various sources claiming these numbers, and we see different numbers all the time. And to me, the point isn't what the particular number is. The point is that it happens almost all the time. That does not always mean total failure, but it often means recovery is slower, narrower, or more complicated than expected. Some of the common issues that we see at Dell Technologies when it comes to recovering an organization is a lack of an incident response plan or a partner to assist in creating that plan. We see a lot of the time the recovery process hasn't been tested, and one of the most important things is proven recovery. So practice, practice, practice. Containment failures. So there could be an unclear perimeter. And we also see a lot of runbooks or playbooks out of date or missing. There just purely isn't one, and people are trying to rebuild the business from memory. There can also be massive problems when it comes to communication within the organization as well, and bringing all of those business units together to understand which business operations map to the technical operations. One that we come across very frequently, actually, but organizations have been a lot more proactive now, is having a trusted environment, which is a set of clean infrastructure to be able to recover instantly. So we're seeing customers now that are moving more in that direction of having a trusted environment. They've got runbooks, they test it, then they can sleep at night knowing that they will be able to recover at least the minimal business critical applications. Other things I've seen when we've helped customers recover is end of life infrastructure, lapse support agreements, things that haven't been patched, they've been outdated. It can sometimes take days to just update all of the infrastructure and software. No telemetry, another one that can delay the recovery process because there's no telemetry going into a central SIEM server. So we have to manually go through those logs. Again, takes time, and time is the essence if you are suffering a compromisation. So I guess to summarize then, planning gaps hit first and the hardest. Operational gaps compound the timeline, and infrastructure gaps can't be solved mid-incident. So the core issue is that many organizations test for backup success, not for operational recovery success.
Yeah, thanks, Amy. That's great. And Eric, same question to you. Can you shed some light on some of the challenges with recovery?
Yeah, so recovery is a frickin' mess. And the reason is because enterprises don't treat a cyber attack as a disaster. It's a fire, it's a flood, it's a tsunami, it's a hurricane. And for those of us that live on the ring of fire, since I'm coming to you live from Silicon Valley, an earthquake. That's what they practice. So when I talk to CIOs or CTOs or CISOs, I talk about how you need a comprehensive cybersecurity strategy as part of your disaster recovery strategy. Amory talked about practice. Do they practice a hurricane or a flood? Yeah. Why are they not practicing a cyber attack? Because they don't think of it in the right way. So you know, end users need to realize, or channel partners that support those end users, a cyber attack is a disaster. The current estimates for the cost to enterprises, forget what it costs us as home users or our families or a small business, but to enterprises, 7 to 10 trillion US dollars this year between the impact of the attack, financial loss of the attack, trying to recover from the attack, and hiring 12,000 consultants at the last minute, overtime because everyone's working 24/7 by who knows how many weeks in a row to get yourself all back because you didn't practice anything, right? And I mean, even some of the global Fortune 500 don't have a comprehensive cyber recovery and cyber attack plan because they don't think of it like a disaster. They imagine a fire, okay? Well, a cyber attack is a fire of your data. Your data is on fire, not the building, not the storage, not the servers, not the networking. Literally, your data is on fire because you can't get to it. When your building burns down, can you get to the servers or the physical storage of the network? No, because it burned to the ground. When it's been encrypted, your data is essentially burned to the ground because you can't get it. So if you think of it that way, and end users think of it that way, it would be much better. They practice, you put together, as Amy pointed out, the run books. What's the strategy? You make sure your systems are up to date, not just your storage, but your servers and your networks, right? Because of course, cyber criminals are attacking everywhere. Primary storage, I'll call it secondary storage. So workloads that don't require as much performance or availability as the primary side, but it's still, primary corporate data. Then the backup side, the archive side, the replicas, because everyone's replicating for the fire, the flood, or the earthquake. Okay, well, if I'm the head of the cyber mafia, since I'm half Italian, I'm going to claim to be head of the cyber mafia. Okay. So as head of the cyber mafia, I'm telling my guys to go after every freaking area where there might be data. So primary storage, secondary storage, the archive, if I can get to it. Sometimes the archive is tape off site, but if it's not, I want that. I absolutely want the backup, and I want the replicas because people think of those mostly for fire or flood protection and don't realize, well, wait, it's the same data. So if I attack that, I'm in great shape. So I think the biggest thing is if end users and the partners who support end users realize that cyber attacks, cyber resilience is a disaster, and practice it and have all the structure that you need. And anyone who thinks they won't be attacked has got their head in the sand. The question is here isn't if you'll be attacked, it's when and how often, and counting all attacks, not just against storage. The average enterprise suffers right now, as estimated by cybersecurity analysts, not storage people like us, over 2,000 attacks every week in the enterprise. 2,000 every week. So they're going to get through one. I mean, come on. We've all seen the old Robin Hood movies. Does Robin Hood eventually get into the castle? Of course he does. Does it take a bunch of times? Of course. And in any one of those feudal movies or a samurai movie, do they eventually get into the castle? They always do. And cyber's the same way.
Thank you, Eric. Yeah, good analogy. I want to pause and read out some of the questions from the audience. So Tom had a question. Again, Eric and Amy, you can answer, or we can open up to the rest of the panelists. And the question is, how are the data protection needs different for AI workloads, and how will that impact backup target storage?
Let me take that first. It isn't different. AI is the new tool. It was the mainframe. Anyone have an iPhone or a Samsung? Do you know that that phone is more powerful than the first 15 generations of mainframe? Okay. So then you had open computing. That was the revolution. The internet was the revolution. AI is the current revolution. In 20 years, there'll be Hinklemeyer, Bleep, Snort, and AI won't be, just like the mainframe isn't the hot thing anymore, AI won't be the hot thing. You have to realize that this is an incredibly impactful time. By the way, that's what everyone said about the internet. Everybody. And was it? Absolutely. Does anyone here not use the internet like every day, or your kids or your wife or your husband? Every day. It was impactful. AI is the same thing. But thinking that it's special, the only thing I would argue is AI, mostly with agentic, is about software. So it's now an additional attack surface. Okay? But the data, the file data, the object data, when you are using structured data, if I'm doing financials, as someone pointed out, that's going to be the structured data, right? The Oracle or SAP system will have financials. So I'm going to use AI to help with that. I'm still going after that data. And if I go after file and object, still file and object. Okay. And AI software itself is software. So if I'm the king of the cyber criminals, I'm going to tell them, and by the way, let's get a hold of all the agentic agents. Boy, that's going to be even better than just getting the data. So don't think that AI is special. AI needs to have the same amount of cyber as everything else. And you need to realize that cyber needs to extend to the AI software itself because it is software, which means it's heavily attackable.
Cool.
I just want to throw something in there, if that's okay with Eric. I do see a unique attack vector, though, which is data poisoning, which is kind of difficult, I think, to defend against. You have to have some sort of pipeline to look for data changes and make sure no one's using nefarious tactics, which again leads to using more AI, right, to monitor our systems. But you've got examples of people poisoning data sets deliberately to have a model push something out which is wrong. A famous example is Google Gemini suggesting we use oil, motor oil, and glue in a cheese pizza recipe because it read Reddit, and Reddit was talking about marketing pictures, about how you get the cheese pizza really stringy. And it's such an issue that governments think it's an issue. So the EU AI Act deliberately points to poisoned models and how to defend against them. So sovereignty here plays a part. I think I agree everything that Eric said, but I think there is a unique issue here that we do need to solve for.
Cool. And Adam, I want to ask you the next question, which is, what can an AI-equipped attacker do today against storage that they couldn't do 2, 3, 4 years ago? And subsequently, what can defenders actually do in response?
Okay, I'm going to start with the positive because I promised I'd say something positive. I feel like when we talk resiliency, it's always the world's burning, everything's falling apart. So I personally think we're in the golden age of cyber resiliency right now, and that's me being me, but I'm a happy chappy who likes to think things are good. Now, with the power of artificial intelligence, really, it's like having 1,000 people at your back. It's like being able to train 1,000 cybersecurity people. And if you're a big organization, they're very hard to get hold of. If you look on LinkedIn, they're expensive. They cost a lot of money. They're hard to train. Now I can use AI to protect my systems. I can look at my workforce and see what they're doing. And if there's someone in my workforce doing something they don't normally do, I can flag it and I can go, wow, let's track that person. Let's stop them from doing that. This is incredibly powerful. This is the first time I feel like we have a real leg up on the bad guys. And everybody out there who's got data should be looking at employing one of these tools to protect themselves. Like, it's phenomenal what we can do. So that's the positive. I would say, though, with every great advantage, as Eric pointed out, we had the internet, we had all these things. It all came with a positive and all came with a negative. And the negative here is, I think, as you saw the UK government write an open business letter to all boards in the UK, say the frontier models are really causing a problem. They can poke holes in your infrastructure and in your environment at lightning speed, and we need to start discussing this, and we need to plan for it. And I think I've also mentioned those really tailored examples of where we've been able to replicate people's voices, or even on the fly replicate a video and pretend to be somebody else. There's a very famous example, I think, of a company handing over a fair few million because a CFO rang up one of his employees and said, do this transfer. And it was totally fake. The whole thing was AI. So I think we've got a couple of unique problems, but we've got an amazing tool at our side here, and everyone should be using it, particularly to protect their data, which for me is the crown jewels.
Wonderful. Love the optimism, Adam. Thank you for that. That's great.
I would also like to add one more thing.
Yeah,
We're
please
already
do.
starting to see government limiting the access to the latest frontier models. Very, very soon it's going to be, that's it. We reached the point where the latest frontier models are what normal customers will get access to. And then it's going to become a possible struggle between open source to the closed source models, etc., etc. Ultimately, it's the classic good versus evil question. You get a better tool, the bad guy get a better tool as well. So the good guys needs to have their upper end versus the bad guys.
Yeah, I'd also say that like AI, it isn't just about the data, it's about the full system state. And like we are having these conversations daily with customers. AI, yes, it should be protected like any other workload, but it also demands additional specialized controls as well. So it's not just about having a backup of your data, backing up the VMs or containers. Security in AI environments, it spans across multiple layers. If you're looking at the data layer, you need to ensure data quality, what goes in, what comes out, the integrity of your data, and of course the protection as well. Then you need to look at the model itself. You need to safeguard against manipulation, bias, unintended behavior, the infrastructure, secure the compute, storage, networking. So there's multiple things that you do have to consider, and the application layer as well. And that's when observability will come in, visibility, auditing, strong governance is required with AI. And of course, the operational side of things as well. So including those blue red team exercises, planning that instant response recovery process, updating policies, constantly revisiting them as well. So it's not really about, for me, the backup or the data layer. It's having that solid security end to end.
Yeah, that's great. Thank you, Itik and Amy. And in fact, Amy, you touched on visibility. I want to ask a question about that. How much visibility do you think storage teams actually have into the security posture of their storage and backup systems? And where do you believe are the biggest blind spots?
Most storage teams have partial visibility. It's getting a lot better now that multiple software vendors are providing a unified experience, and it's all around telemetry, really, collecting that data. Don't seem to see storage admins that have like full end-to-end visibility. The security team may have some management consoles where they're monitoring different things to what the storage admins can see. They typically have strong visibility on like the capacity consumption, performance, availability monitoring. It could be, if it is the backups, the status of the backup, the infrastructure health, basic configuration awareness, I would say, inside the storage infrastructure. But I'd say like the biggest blind spots are usually around identity and access posture. And now we're seeing like more and more of a rise when it comes to cyber attacks, with credential theft being the top risk. So who really has privileged access like in that environment, how that access is governed, whether credentials could be abused. These are all important things that we have to consider. Configuration drift, has someone jumped onto the system, modified anything? So we need to be able to keep that pattern and monitor if there's been a change in the config. And backup environment exposure, we've talked about, 99.9% of the time, they're going to target your backups. They're going to try and infiltrate your backups. Immutability, coverage gaps. I would say now, like most organizations enable immutability. They're aware of it. That's going to prevent their data from being deleted or modified. But we still do see a lot of storage where it hasn't been turned on yet. Cross-domain dependency mapping as well. Understanding how the storage, the backup, networking, Active Directory, all those layers interact during an incident is key. And of course, recovery readiness as well. So knowing not just that copies exist and the data's sat there, but which copies am I going to be able to recover and which is my last known good copy. The reality is that the storage admins often see the platform state, but not the full security state. So by having a management console that can bring all of that together is just invaluable for organizations.
Yeah. And Eric, in a couple of minutes, can you answer the same question around, in your opinion, how much visibility storage teams have today around the security posture of their storage and backup environment?
So Amy brought up a number of excellent points. I'd say even with all of that, it's still at best mediocre. Until the CIO, the CTO, and the CISO consider enterprise storage as a critical component of a comprehensive cybersecurity strategy, storage, primary storage, secondary storage, backup, archive, even the replicas, are all be segregated into their own storage silo. Second thing, and many of the storage admins are so busy just managing the storage, they don't have time to manage the security aspect of the storage. Third thing is there often is silos in IT. Just like you talk about a corporation with the sales silo, the finance silo, the operations silo, the marketing silo, and a big, it's Harvard and all the famous business schools, all kinds of books about siloing. Well, guess what? Sub-functions like IT or any other thing have their own little silos. And I'd say cybersecurity is a silo that often is completely divorced from storage. And then I think the last thing is if you had the right level of integration between storage and the data center-wide cybersecurity posture. For example, Siemens Source software, or many of the bigger companies have a security operations center. We're mostly old enough to remember when the hot thing was the NOC, the network operating center. Now it's like, who cares about a NOC? It's all about the SOC, security operations center. So often storage is not part of that communication strategy, whether you're using an automated strategy, Microsoft Sentinel, IBM QRadar, right, Splunk, all these cybersecurity packages that span, but usually don't talk or touch the storage, and then clearly a SOC. So I think if you have that, then that's the last thing you need so that everything is integrated, okay? IT is a team sport. Storage, network, server, applications, operating processes, it's a team sport, and often IT doesn't run as a team, and cyber attacks are one of the things that come through because the team isn't working as a team to protect themselves and realizing, oh yeah, that's the defensive guy back over there. This is the offensive guy over here. This is the goalie. This is the this, that. I'm not much of a FIFA football person, so I won't use a American football analogy. Patrick's laughing because I know he's from New York, but you want to have a comprehensive play. And that often is with storage not being part of the comprehensive cybersecurity strategy. Servers and networks usually are. Siemens SOAR, look at those. They don't look at storage. So the storage guys need to get themselves a seat at the table and make sure the cyber guys realize that's all great, but you do know like 98% of the corporate data is sitting on our storage, and they're going to attack that. They're not, cyber criminals are smart. And by the way, they're going to use AI, as clearly pointed out. AI is good and AI is evil, right? AI is good, AI is evil. They're the evil ones, we're the good side. And so you got to make sure that that level of integration happens. And then a lot of what Amy's talking about would really explode. Right now, I'd say it's mediocre. She brought up every single element that it should be, but in most enterprises and in the global Fortune 500, it's usually worse because they're even more functionally siloed and maybe even visualized, or the European team is doing something and the US team does something and the guys in Asia do something else, right? Because they don't run consistent and for cyber, attack is an attack. I don't care if it's in Brazil or Singapore or San Francisco, right? So I think that's where the gap really is that Amy was pointing out.
Yeah, very, very valid points. Thank you, Eric and Amy. And we're at the final stage of the virtual event. I want to get to the final question, which is around storage refresh cycles. So storage refresh cycles were 5-7 years approximately. Do we believe that still applies when GPU generations turn every 18-24 months and storage has to keep up? Patrick, can you shed some light on that?
Yeah, no, I think you're right there, Duran. There's still going to be probably this longer term storage cycle, refresh cycle, 5 to 7 years, for certain capacities, like your cold and archive tier, if not a little bit longer. But you're also going to see, kind of like I alluded to before, you have these architectures where GPUs and storage are much more closely integrated. And there I would see storage potentially coming into play in a faster refresh cycle, that kind of 18 to 24 months as companies are refreshing their GPUs. They're going to also need to refresh their kind of high performance or kind of the GPU tied storage there. The other thing I think happens is we're just going to continue to build more intelligence into the SDS layer. And use that. We can obviously ship the software a lot more quickly than the 5 to 7 year cycle, and so we're going to start putting in a lot more logic in there to make systems more efficient and sort of stretch the tiers when we can.
Yeah. And Felix, same question to you around storage refresh cycles. The last word from you.
Just to echo some of my colleagues, I don't think that we're moving away from a long-lived infrastructure. I think that we are moving more towards a continuously adaptable architecture. AI is happening faster than, innovation happening much faster than traditional infrastructure cycle and refresh. So I think organizations they aren't replacing every 2 years. They're building platform that can evolve incremental without disrupting the business. I think, to me, that's more sustainable approach. The future is not just faster refresh cycle. I think it's more architecture that never becomes obsolete. Be able to modularize your architecture. That's how I see it.
Amazing, amazing. Thank you so much. We're a couple of minutes over, but thank you to all our attendees for joining us. There were quite a few questions that we didn't get to answer. What I'm going to do is I'm going to share these questions with all the panelists. I'll compile everyone's answers and we'll get back to you individually. Thank you again for the attendees, and thank you, of course, to our wonderful panelists, Amy at Dell, Adam from NetApp, Felix at Hitachi Vantara, Patrick at IBM, Eric at Infinidat, and Itzik at Vast Data. Thank you so much for joining us today. Really engaging and dynamic panel. Thank you.
Thank you.
Thank you very much for having us.
Thanks, everyone.
Bye.
Bye. Have a good day.
Bye.
Take care, guys.